Wow, the first ever physical activity epidemiology study that focused on occupational physical activity was published by Dr. Jeremy Morris and colleagues in Lancet 1953. Coronary heart disease and physical activity at work. You just read that study, and it's the classic first study for everyone in epidemiology with a focus on physical activity. They specifically looked at two types of employees, all working within this double-decker bus. You had the driver, person who sat all day, very sedentary, and you had the conductor, a person basically moving all day, going up and down stairs, up and down the aisleways, taking tickets, managing the customers going on and off. Dr. Morris and colleagues wanted to contrast the coronary heart disease experience between these two types of employees. Now, as you were reading your assignment, I had several questions that I want to make sure you understand how to answer. So you should be able to tell me what was the purpose of the study, who the subjects were, and how did Dr. Morris select them? How did they measure disease? The results. You note that they were given to you by age category. Why? What rates did you see and what did they report? And do you know what these rates mean? What were their conclusions based upon the rates for coronary heart disease between the two employees? And finally, what did they consider when they were trying to figure out why those results were seen? And they interpret in their interpretation and their notion of what actually was happening. So I know this is specific to this coronary heart disease study, but a lot of these same questions will be you need to be able to answer in any reading we do. So let me walk you through most of these questions. The purpose. Look on page 1. Now they gave a very short introduction. In fact, it's only about 2 paragraphs. The second paragraph that I've highlighted here gives insight into what was driving their picking the London bus transport study. They wanted to extend the literature actually on coronary heart disease by occupation. So they picked this London transport and they picked postal workers, which you'll see on the very last page or two of the article. Their methodology, 31,000 men, 35 to 64 years of age. They tracked the coronary heart disease for them for 2 years. There were no women because women really weren't allowed to work in London with the London transport in these types of job classifications. They picked men between 35 and 64 because, well, at 65 and older, they're more likely to have retired. 35, you're not likely to see much coronary heart disease, but they did include them. A lot of the results you'll see actually started at the age of 40 or 44. Among these 31,000 men, they looked at sicknesses and absences by the records kept by the London Transport system. Many of these may be associated with coronary heart disease. But what they really focused on is the diagnosis of coronary heart disease and mortality records that link back to heart attacks or heart disease. They got those from general practitioners or physicians and hospital certificates and death certificates. And with this, those 31,000 men were classified as having an event or not having an event. And then they contrasted the number of events after converting it to rates between drivers and conductors. They age adjusted both incidence and mortality rates. Incidence rates are new events of heart disease. Of course, mortality being death, they looked at the death rates of heart disease. And then taking these rates that were calculated on 31,000 men, they adjusted those rates for the proportion of men by age living in England and Wales. So it allowed them to extend their examination of these rates if it were to happen to all men, or if these rates were similar to men in England and Wales, what would be the expected outcomes? And I'll go into a lot more of the methodology of physical activity epidemiology in chapter 3. So look at table 1. I don't know what you highlighted in your particular text. There's a lot of great information that you could use, I could ask questions on, but let's just focus on the standardized rate. Now, that's the standardized rates of events, both incidence and mortality, among men between 35 and 64 years of age. And it's reported by rate per 1,000 men each year. And that's for all of the 3 different types of events that they tracked. But let's first look at the total incidence for these 31,000 men of that age category or range. 2.3 events would be expected to be seen each year for every 1,000 men. 2.3. Now, mortality was 0.7 deaths per 1,000 people each year. The myocardial infarction, 1.2 events per 1,000 men per year. And then finally, angina, 0.4, much lower than the other rates per 1,000 men per year. Now, they haven't contrasted yet conductors versus drivers. This is just for the total sample. And they break it down for you by these 5-year age categories with the number of cases and then the calculated rates based upon the men falling in those age categories. Now note, if we looked at this figure in a different way, with this particular figure 1, you can see that as men got older, mortality increased for heart disease and the incidence increased. Now this is not rocket science here. It would be expected because we know age is probably the most important risk factor for many diseases. And I just wanted to illustrate this to you. And that's the reason why we have to age adjust, is because the occurrence is much lower in younger men and higher in older men. In order to get an overall standardized rate, we have to look at age and how it confounds the results in rates. And again, when we get into rates in future chapters, I'll go into more details on why. But for now, realize age is very, very important. So here we see, when you look at table 3, drivers versus conductors, the average annual rates per 1,000 men. Now instead of 5-year categories, we see 10-year categories. And there are 3 categories of age. You can see man years observed. So that's the total number of men, for example, in 35 to 44 years of age. For drivers, there were 12,360 man years. So each person could accumulate 2 years of observed time. So there were probably 6,000 men in that age category. In the 55 to 64 years category for drivers, there were 6,668 man years. Probably only had 3,000 people in that particular category. But if you look at on the very right for drivers, 6.5 coronary heart disease events on average for each year per 1,000 men. Now let's look down at conductors for that same age category. It's 5.0. So the conductors, even at that age, had lower rates of new cases or total incidents. In fact, when we look at the standardized rate for drivers, which is 2.7, compare that to the 1.9 per cases per 1,000 men on each year. we see that the rates are really lower among the conductors, with one exception, angina. Angina is 0.8 for conductors compared to 0.4 for the drivers. So to summarize, total incidence, higher in drivers. Thrombosis, mortality, immediate mortality, it's higher in drivers. Myocardial infarction, higher in drivers. And then conductors, we see angina being higher. That's the only type of heart disease measure that had higher in the conductors. All right, so 3 out of 4 higher among drivers, the sedentary employees. One way to really help visualize this is if you were to create a simple bar chart. You look at conductors and drivers. If we were to look and think about conductors, the more active people, they're half as likely, 50% less likely to experience a heart attack or some sort of coronary heart disease compared to the sedentary drivers. That trend holds out for mortality. If we were to look at it differently in terms of, okay, sedentary is a risk factor, we would say, okay, drivers are twice as likely to have a heart disease event compared to the active conductors. So this was really a big important finding back in the 1950s, and it really drove a lot of the future heart disease research that we saw in the 60s and 70s, funded by National Institutes for Health and other major health institutes. So conclusions. Conductors had 50% less heart disease than drivers. That played out for both incidents or new cases and mortality, deaths. Conductors, when they did have heart disease, it appeared at a later age and it was less severe. In fact, the angina, which is a reflection of benign heart disease, was much higher in conductors, meaning that if they had an event or anything related to it, it was really not that severe. So 50% less likely for conductors. The rates were 50 or cut in half, actually. Now, this is reflective of a lot of our early occupational physical activity studies. They gave you 3 possible hypotheses or explanations of why conductors were 50% less likely or had 50% less more cases. One, the drivers and conductors may have simply self-selected into a job. That people who were more prone to have heart disease may have just been attracted to the driver's occupation because they liked being sedentary. They didn't mind sitting down. They liked driving. And the conductors liked to move around. So it wasn't really the occupation. It was just people were attracted to certain occupations within, or certain job classifications within an occupation. 2, maybe the strains of driving the bus in London traffic may have been such that it caused higher heart disease among the drivers compared to the conductors. And lastly, perhaps the physical activity of the conductors, the movement, may have led to being less likely to have heart disease. Now, they put, and as well as I think we all would put, greater weight on hypothesis 3. This particular study set the stage for all of the future occupational studies that we now know are the early part of physical activity epidemiology as a field. Another study that really found very similar results was the San Francisco Longshoreman study. And you look in your text and you'll see many other studies listed. Together, when we summarize these, people in job classifications that required higher energy expenditure, more movement, more physical activity, saw less risk for heart disease, up to 1/3 less risk, or to 3/4 less risk compared to more sedentary job classifications. Now, these studies gave great insight into the possibility of physical activity, but they had weaknesses. And those weaknesses really drove our transitioning to studying leisure time physical activity and not occupation. And here are the weaknesses. Energy expenditure varies widely in the same job. So we can't say for certain that conductors were more highly active than the sedentary people. Certainly there was overlap. Longshoremen, certainly there was overlap in energy expenditure because not everyone did the same exact thing in each job classification. Then we had perhaps more active workers who got hurt or sick being reassigned to sedentary jobs. So that could sort of degrade the dichotomized energy expenditure thinking between highly active or low active. In fact, you may have had some people in the London bus transit study who were driving simply because they may have hurt their back a year or two beforehand. They were still had protection from earlier physical activity. So it just kind of clouds everything. Then leisure time physical activity wasn't measured. We really didn't know how to, or Dr. Morris didn't know how. There weren't any instruments or protocol. So it's possible a lot of the drivers were active in sports clubs in London. They got a lot of energy expenditure there and they received protection. We don't know that. So a lot of the differences we saw in rates uh, may not have been as great because of not accounting for leisure time. And then other confounders like smoking, alcohol, social economic status, education, things that may indirectly fall between physical activity and actual heart disease. It could be that smoking uh, played an important part in those rates, and it may account for more than the physical activity. We really couldn't say. Of course, statistically, they were challenged to doing that too because they didn't have the sophisticated software we do. And then technology. We know that with new equipment, new technology, energy expenditure, even among longshoremen, has decreased over time. Simply, what we consider manual labor, what was considered manual labor in the 50s, is not the same as that in the 70s. So taken together, we realize that jobs and occupations really aren't the best way to test this hypothesis. Does physical activity provide protection against disease? Or look at it another way, are sedentary employees more likely to be sick or suffer disease than the more active counterparts? Okay, introduction to physical activity, early occupational physical activity studies in chapter 1. I'd like for you to just pause right now, get your notes in order, look at the article again, check the notes that you got from this particular lecture, because I've got a quiz for you